Welcome to my Just Jenny podcast. My guest today is Dr. Richard Johnson. You could check out drrichardjohnson.com. He is a nephrologist as well as professor of medicine in the Department of Nephrology at the University of Colorado. And he is the author of a book called Nature Wants Us to Be Fat: The Surprising Science Behind Why We Gain Weight and How We Can Prevent and Reverse It. Dr. Richard Johnson, welcome to my podcast.
Thank you, Jenny. It's great to be on your show.
So I heard about you from a friend of mine who is an actress and an influencer named Jenny Mollen. She started reading your book and freaked out. I mean, freaked out, and was texting me when she was going to be on this episode with me, with you, but she had to go to a doctor's appointment and then pick up her kid. So priorities.
Okay,
But she was messaging me yesterday that since getting into this book, she's eaten 2 strawberries, period. She's afraid of fruit. And I said, and we're going to get into this, I said, I understand that fructose is an issue. And I've heard rumblings of fructose being an issue for many, many years, but I've heard about it more in the sense of it's not the berries or the apple or the watermelon or the honeydew, that it's the chemicalizing or the concentrating of the fructose and using it as a very highly concentrated sugar in all the foods that are not fruit. So let's start there with, is fruit really dangerous or is fructose dangerous?
I say you get an A on your exam. Yeah.
Yay.
Because first off, fructose is a carbohydrate. It's a sugar.
Mm-hmm.
And it's called fructose or fructose because it's the main sugar in fruit. And this is why you're asking, because what we found is that fructose is actually at the heart of what causes the obesity epidemic. And this is from our work. And so it becomes natural, if you know that fructose is the culprit, to say, oh my God, I can't eat strawberries or blueberries. And by the way, I had blueberries this morning.
Delicious.
So,
yeah.
Yeah, they're
Mm-hmm.
delicious. So let me explain how it works. So, animals in the wild, many of them will use fruit to become obese. And like the bear, for example, will eat fruit in the fall to help it gain weight, and it'll gain huge amounts of fat, which it will then live on when it hibernates. So when it hibernates, it's not eating. So it breaks down the fat that it builds up, and it uses the fructose to activate this nature switch, that allows it to accumulate fat. It makes it hungry. The fat is actually driven by all the food it eats, more so than just by the berries. But the berries contain the fructose that the bear uses to initiate this this kind of magical switch to gain weight. So the big thing to realize is that a bear doesn't eat, a bowl of grapes or a bowl of berries. They eat hundreds of bowls. So what they do is they'll go and they'll just gorge on fruit, and they can eat as much as 10,000 berries in a day, and so they're getting a much larger dose of sugar than we are. When we eat a natural fruit, we're eating, the typical fruit serving would have between 3 and 8 grams of fructose. And, if you're drinking a soft drink, you can get 20 grams of fructose,
Right.
and you'll drink it in about 1 minute. And, but, when you're eating berries or a fruit, you typically get like 4 or 5 grams. And it turns out that the first 4 or 5 grams of fructose we eat is inactivated in our gut. So it doesn't even get to the liver. It gets used up in the gut. So natural fruit, and like the fructose that's in carrots and the fructose that's in sweet potatoes and things like that, it's almost all inactivated before it gets to the liver. Now, the fruit also has a lot of substances that actually counter the effects of fructose. So natural fruits contain vitamin C, for example. And we found that vitamin C actually blocks the effects of fructose. And so certain fruits like kiwi have lots of vitamin C and not so much fructose. And so, they really, they're good for you. And what we found is, the way it works is that fruit tends to, when it, birds will, and animals will eat it to gain weight, but they'll wait till the fruit ripens. And as the fruit ripens, the sugar content goes up and the vitamin C content often goes down. And so they're getting, the plant doesn't want, the animals to eat the fruit when it's immature, and there's not a lot of fructose in it and high vitamin C. And so animals don't want to eat fruit when there's not much sugar in it. So they wait till the fruit ripens, and that's great for the tree because then the seeds can germinate and make more trees. So,
Yes.
so it's all sort of kind of, so when you eat natural fruit, there's also these substances called flavonols, and some of them are really, really healthy. And there's one in particular called epicatechin that's in fruits, and it actually counters the effects of fructose as well. And we've done a clinical trial, for example, where we gave epicatechin to people who are overweight and showed that it could, reduce metabolic or improve metabolic features, like their blood fats and stuff like that will go down. So natural fruits have all these things. They have fiber and potassium. They don't have that much sugar. And we even did a trial where we put people on a low fructose diet, and we improved their metabolic syndrome. But we also had one group go on a low fructose diet where we supplemented them with natural fruits, whole fruits. And it didn't block, it was still quite effective. They still had an improvement in their metabolic syndrome, and they enjoyed their diet more because the fruit actually, fruit is actually, sweet and provides, some satiety and some good things associated with it. So anyway, so the bottom line is you're right. And you should tell your friend to not worry about those strawberries.
Yeah.
And every morning I'll eat a little bit of strawberries or blueberries because they're so rich in so many good things.
Yeah.
And I'm not afraid of the fructose component because I'm only eating a few. Now, if I made juice from it,
right,
and got rid of the fiber and all that, and got 5 fruit in one glass,
right,
and then I would drink it fast, I could get fat. And in fact, I've had people contact me who, cannot lose weight. And it turns out that, after they do their run, they make a homemade smoothie with 5 fruit, thinking it's completely healthy because fruit are healthy, but fruit juice, unfortunately, is not so healthy.
Yeah. I mean, to me, the whole fat thing is so complicated. And I tend to know that you're right in the sense that sugar often leads us to eat more sugar, and fructose, when it's distilled down, like you're saying, almost concentrated, or the bulk amount of it, like in a fruit juice or in a soda, would have that kind of impact where it turns on that switch that tells us to store fat or make fat or increase our appetite or whatever is the technical stuff. But how does this tie into what you do as a doctor? Because how does a nephrologist, because I would think, wouldn't it be an endocrinologist or an obesity medicine specialist who would be kind of sussing out what the root causes of obesity are and how we can help them?
Yeah, I've thought about that. I don't think kidneys get fat like we do. So, and I'm a kidney specialist. So
right,
it's a good question. Why is this kidney doctor, who a lot of the time spends, putting people on dialysis and helping them get kidney transplants, how is it that I became an expert on obesity? And the first thing is that I'm a scientist. I do both research and clinical work, and I've been doing that for too long. I've been ever since the 1980s, and I've been funded by the National Institute of Health. And one thing that characterizes me is that I'm extremely curious, and I want to know why. And I get excited, when I do research. And I mean, I really get excited when I do research, and we've had a lot of discoveries, and I've been involved in the discovery of some diseases, for example. But this has been the most exciting.
Like which one? Like which disease?
Oh, for example, we were the first ones to describe that there's a virus called hepatitis C, and
Mm-hmm.
it's a virus that causes liver disease. And hepatitis is really a word meaning inflammation of the liver. And it's hepatitis C is now pretty much gone because they've got these beautiful treatments. But back in the early 90s, when the virus was discovered, it was really a problem. And we realized that it could cause kidney disease, not just liver disease. And I published a paper when I was quite young, in in the New England Journal, where we showed that it was the cause of a particular kidney disease. And suddenly I had like 50 patients coming
Yeah.
to fly to Seattle to see me
Yeah.
because I had found this thing. And, I was just kind of, putting one thing together with another to prove it. And it's kind of a fun story. But, and another one, we were studying these people at high altitude in Peru that were turning blue.
Oh,
And
wow.
they were turning blue because their blood counts got super high, and some of them had the highest blood counts ever recorded in the world. So a normal blood count is like 40% of your blood is red cells, and
Mm-hmm.
we had a patient with 91% of his blood was red cells. So he basically, the blood was moving very slow through his
Yeah.
system, but he walked in. He was only like 35 years old, and then we
Yeah.
realized he was being poisoned by cobalt. And cobalt is this metal. If
I
you're
was going to
working in
say,
the
is it
mines,
metal? Because I think of nickel can turn you blue.
yeah, it's a bluish metal, and he was
Yeah.
turning blue, but it wasn't from the cobalt, it was from the blood. And but yeah, so cobalt is known to stimulate blood production, and he
Wow.
was working in the mines, it was getting the drinking water. We had to sneak into the mines to prove it. It was pretty exciting. So I've been involved in research, my whole career.
Yeah.
And, and what happened was I was trying to figure out the cause of high blood pressure because
Mm.
that kills so many people.
Yeah.
And no one knew the cause. And so, it's like, come on, someone's got to figure out what causes high blood pressure. It affects 1/3 of the population. And so when I started studying that, it took me into the role of a substance called uric acid and another substance
Mm-hmm.
called, and then sugar. And sugar raises uric acid. And pretty soon we discovered that uric acid could really have a role in causing high blood pressure. And we did a study in adolescents and could cure their blood pressure, hypertension by just lowering their uric acid. It was and we published it in the JAMA,
Yeah.
which is a nice journal. And then we got really excited about uric acid. I kind of became an expert. And for those listening, uric acid is really important. Read David Perlmutter's book, Drop Acid, which is
Mm-hmm.
about uric acid. It's really good.
Mm-hmm.
But anyway, when we were studying that and we realized that sugar drove uric acid, I started studying sugar. And then I
Yeah.
realized that sugar and the fructose component in sugar was actually driving metabolic syndrome, obesity,
Yeah.
fatty liver. And you just follow your nose. So even though it wasn't really related to the kidney,
Mm-hmm.
I started doing a lot of research in it, and I got a secondary appointment in endocrinology, as you
Mm-hmm.
said, and in physiology,
Mm-hmm.
and I've been studying fructose since 2004 or so, and so I
Yeah.
really know a lot about this substance.
So selfishly, because I experienced watching somebody's sodium get out of whack and it being initially mistaken for a high blood sugar, the non-diabetic Hank hunk, whatever it's called, where it's not I forget the name of it because I'm not a doctor, but they thought he had the non-diabetic shock, but it was really a sodium issue, even though his blood sugar was high. So I want to know for me, and then we'll get into how the fructose impacts our weight and why we need to do something to reverse that to not gain weight or to stave off weight gain. And especially, I know in perimenopause and menopause, it can become even more sort of precarious for women. But what is the relationship between the glucose in the blood caused to rise by things like fructose and sodium levels in the blood? How is there an intersection?
Yeah, there is. It's a little complicated, but let me try to explain it. So basically, we found that fructose could stimulate fat production. Okay, I'm going to just begin with kind of like the bottom line. If you give an animal or a human fructose, you activate this biologic switch that makes you want to gain fat. And it turns out that it's fructose is there as a survival mechanism. It actually wants, animals will either make or it will either eat fructose or make fructose, and it will stimulate the production of fat. And
Okay.
and the fat is used not just for calories, but it's used for water. And I'm coming to the sodium thing, but you're going to have to bear with me for a few minutes. So when a bear gets fat and they get fat, I don't know if you know it, but they have a contest in the fall to who can take a picture of the fattest bear, and you get an award if you have the, and it's on the internet, and everybody submits their pictures because the brown bear will get unbelievably fat before it hibernates. Okay, but anyway, when it hibernates with all that fat, it doesn't eat, and everyone knows that. And the fat is broken down to make calories, because it's like a stored calorie. So when you break down the fat, you make calories so the animal can live without eating. It's great. And in fact, people who are really obese can survive longer during a fast than others. And there was one guy who was really, really fat who went a whole year without eating. So, that would not happen. Gandhi wouldn't have survived a week or so. But anyway, so fat can help you survive, right? But what's interesting, Jenny, is that fat, when it's broken down, it produces water. So when a bear hibernates, they're actually getting water from their fat too. So it turns out that fat is not just a source of calories, it's a source of water. And the hump on the camel is fat, and that's to help it when it gets into trouble. And there are all these animals like whales where they make fat to help not just insulate them when they dive into the cold water, but the fat, when it breaks down, provides about a third of the water that a whale uses, because they don't like seawater. It's too salty.
Yeah.
Okay. So fat has another purpose. And when we were studying that, we were going, okay, well, what we've discovered is that if you made an animal mildly dehydrated, if you made an animal really dehydrated, they would break down the fat they had to make water. But if you just kind of like tease them and get them just a little bit dehydrated, just very, very mild, they actually make fat. And so they're making it to help protect them. And that's how salt works. So when you eat salt, you actually can also make fructose from a high salt diet. And the salt activates an enzyme that converts glucose, which is our normal carbohydrate, and it can convert it to fructose. So you don't have to eat fructose to make fructose. And, so you can make fructose from high glycemic carbs. And we had this big discovery that bread and rice and potatoes, when you eat them, you make your glucose goes up in your body, and some of that gets converted to fructose. And it's really stimulated if you're a little bit dehydrated, like very mild. And that mild dehydration, causes the glucose to be converted to fructose. And that's what salt does when you eat a salty meal. That's why salted French fries are so much worse than regular potatoes, because the salt stimulates the fructose production from the potato, because the potato has glucose. And then the fat on the French fry is kind of like the firewood that helps the animal gain weight. All right, so that's sort of how it works. So while we were studying this, when we realized that, that salt and dehydration might help drive obesity, especially milds, when it's mild dehydration, we realized that there's a hormone that is activated by salt and by mild dehydration, and it's called vasopressin. And this hormone's released from the brain, and it helps animals hold on to water because it makes the urine concentrated. So when you're out walking in the Grand Canyon and then you go to pee and there's hardly any urine and it's all really yellow and putrid, that's because most of the water has been reabsorbed into the body by this hormone vasopressin. And what happens is you're just kind of getting rid of the urea and, you know, the bad stuff. And that's what, and you're holding on to water because the body doesn't want to get dehydrated. So it produces this hormone. And when you eat salt, the hormone's produced. And so it turns out that that hormone had been reported to be high in people with obesity. In fact, that hormone has been reported to predict who gets obese. So if you measure that hormone in your blood and it's elevated, it turns out that it predicts not just obesity, but diabetes, hypertension, kidney disease, heart disease. But it's really good at predicting obesity and diabetes. And people who are obese and diabetic tend to have high vasopressin levels, and they tend to be mildly dehydrated. And so we realized that mild dehydration was a cause of obesity and salt. And we did studies and we found that drinking water can correct the mild dehydration, and it can actually reduce obesity in animals. And so those people running around with the bottles
It's a good
of
idea.
water. Yeah, it's a good idea. It's not a myth, man. It's not a myth. So it turns out that we had this marker, vasopressin, which, you know, goes up when you get dehydrated and helps hold on to water. And we said, you know, what if that hormone actually helped you help make the fat? Maybe the hormone's involved in how salt causes obesity. And so what we did is we did some studies and we found that vasopressin actually, you know, vasopressin is a hormone, and so it binds to receptors, and then those receptors, you know, on tissues, and then the vasopressin works through these things. And so, you know, there's a receptor for vasopressin that no one really knew what the function was. It's called the V1B receptor. No one writes about it because no one knew what it did. But we found out that that actually drives fat production. And so vasopressin, when it goes up in your blood, it's helping you store fat, because that's another way to store water. There's not water in the fat, but when you break down the fat, you make water.
Turns to water, right?
Yeah. So animals will raise their vasopressin levels to hold on to water. Now, getting back to your question.
Yeah.
A
How
low
it
serum,
relates,
when you have a low serum sodium, it's
or
a
a
very
high serum sodium.
or high. Yes. So it's both are important. So we'll go through both of them.
Okay.
So so when you get dehydrated, you're losing water, and your serum sodium tends to go up, tends to be high, and that stimulates vasopressin, which then helps store fat. Okay, so that's what happens. And when you eat a salty food, and we did this study in people, we can show that vasopressin goes up within minutes, and it's associated with activating this switch. Well, we can show your blood pressure goes up, everything, and you start, you know, you're going to want to store fat. So vasopressin is a bad guy because it drives fat and diabetes, and it's activated by sugar and salt, but it's also activated by dehydration. Now, if you're dehydrated, vasopressin is a good guy because it helps you hold on to water, so you don't, you know, it blocks the dehydration. It treats the dehydration, or it helps the dehydration. Okay, so now we go into a very interesting thing, which is there's this condition that people who have cancers and, you know, who are sick, they can get a condition where suddenly their sodium is low. And the problem is that they have an inappropriate stimulation of vasopressin. And so they have high vasopressin levels, but they're not dehydrated. In fact, they usually have normal hydration, but something is turning on this hormone, and no one knows what's turning it on. And so they have this high hormone level. They start holding on to water, And when they hold on to the water really bad, it makes their sodium fall, and then they can have seizures, and and they get confused and they can't think, and then you correct their sodium and their mental status comes back to normal. But so the question is, what drives the abnormal stimulation of vasopressin? And I realized that that when the body starts making fructose, it will stimulate vasopressin. So what if the body starts making fructose when you don't really need to store fat?
Right.
And it turns out that one of the ways you can stimulate vasopressin is under conditions of high stress. So yeah, and I was thinking that with cancers and things like that,
Yeah.
that maybe that fructose is being produced
Right.
inappropriately.
No, for sure. For sure.
And,
Yeah.
and so we got samples from people with low serum sodium, and we found that they had fructose levels that were high,
Wild.
like in their urine. And so we
Wild.
believe that it could be causing, that activation in like a stressful state, like in cancer, might
Yeah.
lead to this, which is an attempt by the animal to try to store, it wants to protect itself, but it can cause the dropping of a serum sodium. And we also have been wondering that this might have a role in the low sodium that occasionally occurs in people on marathons, because it's usually people who get a little mildly dehydrated initially, and then they start drinking a lot of fluids. And we've been concerned that if they're drinking a lot of fluids that have sugar in them, that the fructose might end up initially helping to stimulate vasopressin, which would be a good thing. But if you keep stimulating the vasopressin and you keep drinking water during the run, then maybe you could hold on to the water inappropriately and get into trouble. So we just published a paper on this, and it's relevant, I guess, to what happened to your dad. I'm sorry about that, but I'm
Yeah,
glad
no, it was just
did.
his sodium actually gone really high. But the fact is, what I'm learning is that our systems are so sensitive and so intricate that they're all interconnected. So
Yes.
if your glucose is wonky, your sodium can get wonky. If the hormone you've been talking about the level is not appropriate for
Yes.
your body, then it's going to cause other systems within potentially to
Yes.
break down in ways that make you disoriented and foggy and out of whack, because we need, which goes back to the job of the nephrologist, to keep all of our levels in our blood in a homeostasis spot where we are well, as opposed to these sort of erratic things that go on, which make us feel incredibly unwell. Which makes sense, because how many times have you been somewhere where you haven't had enough to drink, or you had too much salt, or you haven't done this, or you should have done that, and you can get foggy, and you can get weird, and you can just feel off. And I'm sure if any one of us, our blood was taken in that very, very moment, or urine was tested in that very, very moment, something might show up like, oh, you're out of whack because of this, this, or this.
Yeah,
but it's not
absolutely.
so severe that it's a chronic thing. It's just in the moment, it's an acute momentary something, and then we go back to our regular better habits, and it
Yes,
remedies itself.
absolutely. That's very common.
Yeah. So how does the fructose, the sugar, how does it impact overall fat then? And do you feel like if we were a society that just gave up the added sugar, that it would eradicate obesity? Is it really that simple?
No, it's not that simple.
Thank you. Okay. Thank God you said that, because it's not. I mean, it's just.
So what happened was, originally when we found that fructose could induce all the features of the metabolic syndrome, I said to myself, this is great. All we have to do is cut out added sugars and high fructose corn syrup. And actually, I should be able to still eat my potato and all this stuff because it doesn't have fructose in it. And then, as I mentioned, we had this dark day where we realized that it wasn't just the fructose that you ate, it was the fructose that you make, and that the body can make fructose. And this was really depressing. And because we found that, so the way you make fructose is from glucose. So any of these high glycemic carbs like bread, I love bread. I mean, I'll be honest, I really like fresh toast and I just love it. And anyway, but bread is a culprit and it raises the glucose in your blood. And then some of that glucose gets converted to fructose. And same with potatoes and rice and cereal and chips. Potato chips are really bad because they have that salt
Oil and the salt, yeah.
and the fat.
Yeah.
So the trouble is that high glycemic carbs are a major way to make fructose. Now there's this really huge movement that I know that you've had people on, which is the low carb movement, and low carb diets are very effective at helping people lose weight. And the thinking was that it's because when you eat glucose and carbs, it stimulates insulin, and insulin puts fat into your body. And so it's all about that. And people go around and they get these glucose monitors, and then the glucose monitors can give them a reading of what their glucose level is when they eat. And they go, oh, I just ate this cookie. My glucose went to 140. My insulin's surging and I'm going to get fat from that. And so they're cutting out the high glycemic carbs and keeping the glucose down, and they're doing very well. And when we did our experiments, we actually can prove that this is a mechanism for obesity, that the insulin does drive fat as expected. And if you eat a lot of glucose, some of it's being turned into fat from the insulin. But it turns out that most of the metabolic effects of carbs are coming from the fructose that it's being made. Now, the good news is it's still being turned on when the glucose levels go up. So nothing really changes. I have a glucose monitor, and I use it to watch my glucose and to make sure I don't get my glucose levels don't go too high. But I'm not as worried about the insulin as I'm worried about the fructose. But they both happen around the same. They get the glucose levels to about 140, and you're making some fructose. So it turns out that it is so it isn't just cutting out fructose and sugar. You have to reduce all the foods we love, rice, potatoes, chips, cereal, bread, I love bread. So anyway, so that's one thing. And then we learned that the salt makes it easier to make fructose, but to make fructose, you have to have glucose around. So if you're on a low carb diet, you don't have that much glucose around. So a low carb diet is just a great diet, keto diet or low carb. You really you're not eating fructose because it's a carb, and you're not making fructose because you need to make fructose from carbs. And so, we do make some glucose from protein and from fat, but most of the glucose we have comes from the carbs we eat. So the glucose, the production of fructose is really reduced in a low carb diet. But salty foods and also it's really disappointing, but we found that that umami foods, these really savory, great tasting food, why Caesar salads taste good and why beer tastes good is not just the alcohol, it's the yeast that gives it that taste. And that taste is called umami. And interestingly, that umami taste, umami foods get converted to uric acid. Part of almost all umami foods generate uric acid. And then
wait a minute. But wait a minute, Dr. Johnson. If you're telling me that umami foods get converted, Caesar salad gets converted. I mean, this has been my food of choice this week. I've just wanted romaine lettuce with Parmesan cheese.
Yeah, so I got good news for you. There's a good ending.
Okay.
Yeah. So, but here's what: if you take an animal and you give it umami foods, if I put it on, and and so you really can accelerate it, like red meat, which we all think of as, a lot of people think of as healthy. There are a lot of people out there probably on carnivore diets and stuff. And red meat, is like your classic carnivore diet, right? But processed red meats have salt on it. So the salt is going to help convert glucose to fructose. And then the red meat gets broken down. It contains glutamate and these nucleotides that stimulate the umami pathway, and the umami makes uric acid, and then the uric acid also acts to help make fructose. So when you eat, what I'm telling you is that if you ate a steak and you put salt and, a little sauce on it, and you ate it with potatoes, the meat will act like salt. The umami and the salt will help you convert the potatoes into fructose. Now, if you're on a carnivore diet and you're not eating a lot of carbs, you're safe, because, you're not fully safe because your uric acid go up and you could get gout and things like that. But in terms of making fructose, if you're not eating a lot of carbs, you're sort of safe because you're not going to make a lot of carbs. So even though the meat helps make stuff that converts glucose to fructose, if you're not eating a lot of
Then
cereal, rice
to be converted. Right. Okay.
Right. So that's the issue. So, and Caesar salads have a little bit of umami in it. But we actually did, I saw an analysis that I talk about, and it's the umami from seafood and meats that is more likely to generate the uric acid. So you like the umami veg foods, cheeses and things that have umami tend not to make as much uric
be a problem.
acid.
Okay. So my romaine lettuce with Parmesan cheese, and then I squeeze lemon and maybe olive oil, because I don't really like Caesar dressing because I don't like anchovies. But yeah, okay. So
the anchovies would be the most
uric acid
likely
problem.
to raise
Right.
the uric acid.
Okay.
Yeah, I love Caesar salad too. That's a go.
But the carnivore, the probability that the bulk of society is going to be carnivores and be on a carnivore diet, or really live their lives on a low carb diet, doesn't seem all that likely. And for some of us, I tried Atkins at 25 and failed miserably and gained a pound. I was like the village loser. Like it did not work for me on my body type. By the way, lots of carbs don't work for my body type. Nothing works but calorie reduction. Now I know. Lower your calories. No one wants to talk about that. Well, you're reasonable, but there's this school of thought now that calories don't matter. And I know what the real thing is. It's not that calories don't matter. It's like the type of calories matter, and the type of calories you have impact how your body metabolizes it. And that's why not all calories are created equal, but a calorie is a calorie, etc.
Right.
So how do we get this to work for us? This concept of, okay, let's lower down the amount of fructose we're either creating in our body because we're eating things that aren't fructose, but they're turning into fructose, and also eating less, just fructose right there. How do we figure out the right balance so that our bodies work the most efficiently without it compromising our comfort in life? And I don't mean that everybody has to be eating cake all day. I mean, being reasonable about it.
Yeah, yes, absolutely. So that's, so I do go in my book, I actually try to present a balanced diet where you get to eat carbs, and you can eat a little bread, and you can eat cake on your birthday. So, so I've tried to put together what I consider is very, very reasonable based upon our work. But basically there's two things you want to do in the big picture. The first one is you want to not activate the switch very much. It's impossible not to activate it a little, but there's ways to not activate the switch. And so one is to for example, we just talked about the fact that, soft drinks are like the best way to activate the switch. So don't drink soft drinks. My God, don't drink soft drinks. Don't, read packages and try to eat foods that have don't have high fructose corn syrup in it, but you know, you're going to eat some. So don't like never eat it, because like 80% of the foods in the market have
They
it.
haven't,
So,
right?
so it's going to be very hard not to. Okay. You're going to
Right.
get some, but what do you do when, you know, so there's some tricks, you know, for example, like if you're going to eat bread, eat it in the middle of the meal, because if you
Mhm.
eat it in the beginning, the glucose levels will shoot
Up,
up and you'll make the fructose. But if you got food in the stomach, it's going to be absorbed
slow it down.
more slowly. So,
Mhm.
you know, don't eat the bread when they bring it in the basket, but eat it during the meal if you're going to eat it. And, you know, you can do things like put spreads on it. Like,
Yeah.
I did this thing, you put avocado spread. If you make a sandwich with an avocado in it, my glucose level doesn't go up. Now that might just be me, but it's, you know, obviously it's slowing the absorption of the carbs. And, you know, so tricks like that, drinking water. I drink a glass of water before each meal. And I know that that's going to help turn off that vasopressin. It's,
Oh,
if you
interesting.
get thirsty, because, once you get thirsty, you've kind of activated the switch a little bit.
Yeah.
So if you're,
Yes.
and so drink water before you eat the pretzels, not after. Don't chase the thirst with water, prevent the thirst. And, you know, so that, you know, another, you know, trick is, you know, just cut back a little bit on salt, you know, that will help. And so there's all these different tricks. Vitamin C actually is an antidote. So take vitamin C every day. We're going to
Yep.
publish a paper shortly showing that it really does have an effect on obesity.
That's
And so
amazing.
vitamin C, 500 milligrams a day or a gram
Yeah.
a day. You know,
Yeah.
there's all these things you can do. And you know, coffee actually counters some of these effects. I know a lot of people, there's some controversy about coffee, but it really probably has a protective effect in diabetes and things like that. So anyway, so you know, so read the book or just go to my website or just learn from what I told you on this podcast, but you know, keep well hydrated, and all these things can help. Now, that's good for not activating the switch, but then what do you do for losing the weight you already have, and how can you reverse obesity? So the problem is that the switch sort of activates the process to become fat. But once you're fat, you will have to you know, do intermittent fasting or things like that to
Really
help
hard.
lose the weight,
Yeah.
because just stopping activating the switch doesn't make the fat go away.
Mm-mm.
It may over time, but you really have to burn off the fat. And so you're going to have to do some kind of intermittent fasting, or low carb diets can cause nice weight loss because of, for a variety of mechanisms. And so there are
You get
different
so
ways you can do
bored that
it.
you put yourself in
Any
a calorie
caloric
deficit.
restriction will work.
Yeah. Right. That's
Okay.
why the low carb
Any
diets
caloric
work. Yeah.
restriction will work. But okay, but then
Yeah.
there's the final thing is to stimulate the energy factories, because the way
Mhm.
fructose works, the way it works is that when it's being metabolized, it depresses, it really suppresses the energy factories. And this is how it works. It reduces the energy production by our mitochondria, which are those little things in our cells that make the energy that we live by. So we make energy and we store energy. And when we make too little energy, our cells feel that there's a low energy state, even though they may have fat, which fat is a stored energy, but it's not there as an active energy. So the problem is that these mitochondria aren't making very much energy. And initially, when fructose works, it's temporary. It suppresses the mitochondria, so they make less energy. And then, you know, when the fructose wears off, the energy comes back up. But if you do this chronically, if you're like activating the switch every day, and you know, suppressing those little energy factories day in and day out, over time they get damaged because we suppress it by doing a thing called oxidative stress, and it's sort of like UV light. You know, you get sunburned and it can damage your skin, and in this case, you're getting oxidative injury to the mitochondria. And over time, you start losing those mitochondria. And then suddenly you don't have the factories to make the energy, and you're running around with low energy all the time. Even if you stop sugar, even if you stop all the and doing
Right.
everything you want, you're in a low energy state. And it's like, oh my God, how am I going to get out of this? Everything I eat makes me gain weight. I'm like trapped. And the way to get out of it is tough, but there is a way. The way is you have to stimulate those mitochondria to come back. And the incredible thing is they can. And all you have to do is, you see these like Tour de France people who have these like super mitochondria, and they're doing it from exercise.
Yeah, I
And
know.
I have a good friend who does this thing where he takes people with sick mitochondria, he measures it, proves that they have it. Then he just puts them on, stationary bike, and they do like 40 minutes at a time.
Mhm.
And over a few months, you can increase the mitochondria in an incredible way.
Exercise is really,
yeah. So it's that's what exercise is for. It's not to lose weight. It's
No.
to improve the mitochondria. That's what it does.
Yeah.
So what I recommend is
Yeah.
stay active,
Yeah.
walk
Uh-huh.
wherever you go, and walk fast so that you barely can, you can talk, but you can't talk very easily. And when you're doing that, that's the perfect level for stimulating the mitochondria to grow.
Yeah.
And then cutting out on sugar and salt actually helps the mitochondria grow even better.
I
They're cutting back, not cutting out, but cutting
right,
back.
cutting back. I talked to this woman, Katrine Tudorlock, Dean Katrine Tudorlock. She's a PhD, and she studies the impact of walking. Fascinating stuff about cadence and how many steps per minute you really need for it to have a positive impact on your metabolic health. It's really not that hard to achieve that.
Yeah.
Like we think it's something, grand.
There are these studies that show that if you look at someone and they're this isn't meant to be creepy or anything, but if you just kind of look at the pace that a person walks when they're not thinking, that pace is a very good marker of their mitochondrial function. So like if you walk slow, just in general, and it's not because you got a bad knee, and it's not because you got a hip replacement, but you're just walking slow, and this is your normal pace, your mitochondria are likely to be not as good as that person who's just walks right by you. And I've noticed, that young people maintain a good pace. Even people who are overweight that are young will walk by me. And I know that even though they've gained weight, their mitochondria are still pretty good. They can recover. And when you first get overweight, you can lose it very easy. Just in 1 week, you can lose all that weight. And it's because your mitochondria are really good. But as you get older, and once you get to be, 65, and you've been obese for, 3
however many
decades,
years,
then it is like a bear to lose weight. But it's possible. That's the great thing. It's possible. So
are you going to study the GLP-1 agonists? And the GIP and the GIP with the GLP?
I find those very, very interesting. I think they
fascinating,
must,
right?
They must intervene in our mechanism.
Something.
And so, yes. And, part of it is because they just kind of reduce appetite. And part of that is from slowing the gut and, gas and all these things that are kind of side effects. But there is a real benefit on true appetite. So it's working. There's some people who think it's working centrally in the brain. And so, I do think it's a wonderful addition. It's not that I recommend people to be spending all this money, but there are probably some people who can avoid bariatric surgery and things like this, where it really provides a major benefit. If you're just a little bit overweight, I don't recommend it. It's too expensive. It has too many side effects. And I think you can do things with diet much cheaper and it's probably healthier.
Mhm.
But if you're like really overweight, it is a fantastic addition to helping people.
Yeah, to the overall
Yeah.
approach. I think the overall holistic approach for everybody is what's,
y- That's the
without
way to go
stigma,
first.
without, yeah, I mean, yeah, I just look at it like obesity, the field of medicine is just going to keep having more research, more people involved in it when modalities and therapies like this come into play and it starts to lessen. I mean, right now we're still highly stigmatized in general obesity, but hopefully it'll lessen it so that there can be the research to really figure out what all the mechanisms are
Well,
for
nature
all of
wants
it.
us to be fat. There
That's
shouldn't be
clear.
a
The name of
stigma.
this book, by the way,
There,
you're
there
right. I
shouldn't
mean,
be a
you're right.
stigma.
And
Honestly,
yeah, and the way you said about the mitochondria and the lowering of energy, I mean, that's the other thing. Nature wants us to be fat, especially when we've been fat. Nature doesn't want us to stay in our new
right.
weight set point. It's
And
going to do
it's
everything it can to bring us back.
not your fault if you're
Yeah.
overweight. It's
Yeah.
not your fault. We're in a world where these foods are everywhere.
Everywhere.
Everybody is at risk. It can happen to anybody, and it's not your fault. And you can't just reduce calories. That won't be enough. You need to understand that some calories are more likely to, cause problems than others. You need to know about the benefits of exercise and all these things. But
So important. Is it
yeah,
is it fair to say before I let you go that when you are a perimenopausal or menopausal woman, it's even more important to watch how much ultimately fructose ends up in your body, either by your
oh
body's making it
yes,
or eating it, right?
yeah, absolutely. When a person goes through menopause, suddenly their risks for gaining weight and
Mhm,
blood pressure, hypertension, and kidney
mhm,
disease, and everything goes way up. And one of the reasons we believe is because women have lower uric acid levels than men because of estrogen. And when you
mm.
go through menopause, your
You
uric
lose
acid
it.
goes
Yeah.
goes up. And the uric acid is, as I say, an amplifier of this fructose switch. So once your uric acid goes up, the bread that you eat is going to be more likely to make you overweight because that uric acid is kind of like
Mhm.
putting salt on the bread.
It's like a bad joke. I mean, honestly, yeah, it's like a nightmare for women because our
I
cravings changed. We want the bread. I want the pizza. I want pizza every day, or at least for like 10 days a month. I'm like, can I have more pizza and then some more, or another variation of pizza?
Yeah,
Might be grilled
pizza.
cheese. It
Yeah,
might
yeah,
be,
that the tomato and the cheese and the
I mean, come on.
sausage and yeah, they taste good. I totally get it. And
Yeah,
so but so I'm not telling people never to eat a slice of pizza because
right.
someone will take a picture of me eating one and
Of
that'll
course.
be it. But I think that what there's great power to knowledge, and when you read read all these things, and
Yeah.
hopefully some of it will
Oh, yeah.
help guide you.
Oh yeah, no, it's a very Nature Wants Us to Be Fat. It's comprehensive by Dr. Richard Johnson, and you could go to drrichardjohnson.com as well. Oh yeah, I agree with you because then you look at the little things you could do: fidget, move around, exercise, move more. Treadmill desks are great. Keep active and don't eat 12 hours of every day. Like maybe you can eat for 8 hours each day or 9 hours each
Exactly.
day. We don't have to be eating all day long. And look, on a day that I need to eat pizza, maybe I'll stop eating at 4 in the afternoon. It's no big deal. Like you can
Right.
mix and match kind of how you want to work it so that you get to have the healthiest body, which is different for each one of us. It's not about like what size you have to be. It's about how to have the best metabolic health so that you don't have your,
Yeah,
you know,
absolutely right.
whole systems breaking down. Thank you very
Absolutely.
much for being
Thank you.
on my podcast. You're a super smarty pants. And other than your website, are you on social media?
Yes, I do have Instagram, Dr.
Okay.
Richard J. Johnson, and
Okay.
I have a Twitter account. And yeah, you can, a lot of that I think you can reach through my
Through the
website.
website. Okay. Well, thank you for being on my podcast. I'm at Just Jenny Hutt on Instagram. I'm at Jenny Hutt on TikTok and Twitter. And any questions or comments about today's episode, you can email justjennypod@gmail.com. And I will talk to you later. Thank you.
Bye.